Hi guys, Craig here, welcome back to the channel. So what I've got here is an AtemPower 100 amp hour power hub with 40 amp DC to DC. Haven't had a good look at it yet. AtemPower reached out to me, asked me if I'd like to do a review on this. They saw the review I did on their battery. They've taken the feedback on board. They said they're going to make some changes and possibly send me another battery when they make these changes. Now, that first AtemPower battery, just to make it clear, I paid for that myself. And this one, AtemPower have sent me this at no cost to review this product. But as Craig does, it'll be the no bullshit review and we'll see where we get to. So it came packaged in this, packaging was fine. No complaints with that. Okay, so that's what we've got there. Saying it's 3.2 volt prismatic cells. It's got Anderson plugs on it here. I've just taken this cover off so I can show you the plugs on the side just to make it a little bit easier. So you've got Anderson, large Anderson there, which is like 120 amp, I believe. Cigarette lighter, obviously battery terminals. And then you've got, I'd say DC in and solar or whatever it is, I'll work it out. First thing I'll do is going to take the cover off it, make sure everything's okay inside, see what the build quality's like, and then I'll come back and put it through its paces. Also comes with this display, which plugs in here. I'm assuming that's for an internal shunt or something like that. I have no idea at this point. So there's the specs on it, if you guys want to have a look at it. So I'll pull the cover off now and have a bit of a look at it. Okay, cover's off. We've got prismatic cells here, 4 of them. We've got the BMS here. This will be the DC to DC 40 amp controller. The other side here are Andersons. Okay, it all looks good. Oh, what have we got here? Okay, so loose terminal straight away, you can see that. Where's these ones? Oh, okay, loose terminal, look at that. Sure, oh, and this one as well. Loose terminal on this positive. Okay, so you can see that's definitely loose. That one's loose. And that one's loose. All right, so what I might do is, okay, how am I gonna, I'll have to tighten these terminals up before I can start. The problem I've got is getting under here and not touching anything and getting myself into trouble while trying to tighten up the terminals. All right, leave it with me. I'll be back after I tighten them up. You know, just rethinking this, I'm not going to tighten up these terminals. I'm going to do the test on this system, how I found it, and let's see what happens. I think the average consumer out there, it would be the expectation that when they receive this unit, there is no flaws and it works perfectly. No one's going to open it up like I have and check everything. They're going to trust that the product was received in good working order. So I'm going to connect it all up, see how much heat is generated by these loose terminals. Okay, I've connected up the display of the AtemPower, and that's obviously for the shunt that we see here. And I've put a small battery charger directly onto the terminals, which is your input or output. They say it's both. It's only a little 4 amp battery charger, so that's not even going to generate any heat that'll affect those terminals. So I'm not too worried about it at this point in time. I just really wanted to see what would happen. So as you can see there, battery's at 13 volts. It's getting 3.9 amps in, which is 51 watts. And what's this counter doing? 25 hours, 17 minutes, 45 seconds. And 1.6 amp hours. I'm assuming that's remaining. I have no idea. I'll try and work that out. Okay, so that works, but what I'll do is I'll put something on here that's a bit more, you know, I'll put a solar panel out or something and put, you know, 20 or 30 amps into it and see if that actually generates any heat. Is I've plugged an unregulated solar panel, which I've got outside in the sun, straight into the Anderson plug here on the side, and I've plugged in the meter, which is going through their shunt, and it's saying we're getting in 261 watts at 19 amps at 13.5 volts, and I've checked that with a multimeter, so it's coming in unregulated, going through their DC to DC converter charger, whatever you want to call it, and then charging up this battery pack. So that side of it seems to be working. I haven't put a big load on these terminals yet, the terminals that are loose, and I've left that one loose as well. So you've got a small load of whatever it was, 20 amps running through it. So that all appears to be working fine. I've got no issues with any of that. I'll test the output and the larger input. And then I think that's about it, guys. Hey, look, it does come with other Anderson plugs, so color-coded Anderson plugs, which would make your life easier. And then it comes with the other end of the 120 amp Anderson as well, which, you know, would be handy. It's got these brackets here, so they bolt onto the sides. They bolt onto the sides here where these holes are, and then so you can secure that in your back of your ute or your vehicle or whatever. Compliance, in terms of meeting Australian standards and the new, you know, IEC 62169 on lithium batteries, I have no idea whether this complies, so do your own due diligence on that one. The metal case, it seems quite all right. I could have probably reduced the footprint a little, you know, maybe doubling this up a little bit, but I see what they've done. They've made it as slimline as possible, so yeah, I don't really have any problems with that. Yeah, so I'll do a few more tests on it. This seems a little clunky, but you know, it's okay. It doesn't turn off after a period of time, I've noticed. So it just stays on. That could be annoying for people. I guess you could put a switch or something through it. Yeah. So just looking at the parameters for this as I'm charging it up with 50 amp, there's no actual maximum charge current. So maximum continuous discharge current of 100 amps and a maximum charge current with the 50 amp Anderson and a maximum charge current with the 120 amp Anderson, but no charge current maximum straight off the terminals. Now, you can't assume that it's a 1C battery based on that. I just had a quick look and went 100 amp discharge, so I assumed it would be 100 amp charge. But in this case, it doesn't look to be. So what I might do is wind up the charge current and see whether the BMS trips, and then I guess we'll know. So if we just go into DVCC and we'll wind it up to say 75 amps. Click OK. Okay, so now as you can see that the charge current has come up. So if the BMS trips and the FET's open, then we'll know it can't take more than somewhere between 50 and 75 amps. Again, I still need to keep an eye on these temperatures here. Yeah, but to me that's a bit strange. Okay, so I've been running that higher amp charge rate in it for some time now, and it seems to be holding all right. I'll just go back into here. So I've got it set at 75 amps and it's reading 90 amps here. So it's probably got 100 amp BMS in it by the looks of it, because it seems to be holding fine. So I might just crank it up to it. Let's go 100. We'll see whether it holds. It usually will. If it's 100 amp BMS, you would expect it to hold. So, okay, so it's cranking up now. I mean, it's not 123 amps. So you'd expect that to hold. Normally they rate them about 10% over. So you might put it up a bit more to like 110, 115, see whether it cuts out. There you go. So it's saying it's got 99 amps going into it. Here we're showing 125 amps. I've also got it set at 14.6 volts charge, which was what was in the spec of the thing. So we'll let that keep going. It's interesting, I haven't had it on for that long, winding it up at this temperature, but I just wanted to see what the terminals are doing. And as you can see, they're the two loose terminals that I'm putting the heat gun over. And it's not that bad actually. So we've got 50 degrees here. See, that was another loose terminal, so you would expect that one to be hotter, but this one that was tight is actually hotter than that one. So it's not really causing any issues. And it may not in the short term, but long term it may give trouble. It doesn't sit right with me that there's loose terminals there, that's for sure. All right, we'll let this finish charging up. And then I'll do a discharge test on it and that'll be it. Just might bring this charge current down a little bit. £65 amps. I feel better with that. And the reason I say that is because I haven't played with this before, and I'd like to put a bit more of a conservative charge into it, let it do its thing, and I can go away and I feel a bit more comfortable than putting a massive amount of amps through it, and while it's unsupervised. Okay, so it could be battery over voltage protection. The buzzer will beep beep for 3 minutes when the voltage of the battery is 0.4 volts higher than its fully charged status. It will also, the buzzer will beep for 3 minutes if it's over temperature. And well, I guess it's beep beeping. I'm not quite sure. We'll see if that cuts out. But look, now it's fully charged. I'm going to do a discharge test on it. I'll probably do whatever setting number 1 is on the fan, which is about 60 amps. So we'll discharge this battery, and I'll come back to you halfway through the discharge test. Oh, might have stopped beeping at me. No, it hasn't. Surely it's got to be more than 3 minutes now. Look at the voltage here. 14.4, 14.2, 14.4, 14.8, 15 volts. I don't know why it's doing that. There's actually no current going to the battery. Yeah, I'm not sure what's going on. But it's definitely been beeping for more than 3 minutes now. Okay, so discharging now, and you'll see it around that 62 amps, which is about what I charge discharge at when I'm using the fan heater on the low setting. So that seems to be about the same number, 800 watts, 62 amps, as it is on every other battery I test. But interesting here, it's showing 81 amps and 1049, 1050 watts. So there's definitely a deviation issue between the two systems. We'll let this discharge now. I've reset the shunt. We'll see if we can get the 100 amp hours out of this battery. Down to 71% now with 27.7 amp hours consumed, and we've got 64% on the AtemPower shunt display. So yeah, the deviation seems to be growing a little bit there. An hour 5 time to go versus 46 minutes, but obviously that's based on 1050 watts and that's based on 789 watts. So yeah, you would expect to see those differences, but why are they different is the question. So down to 12.14 volts now, and we've made 90.8 amp hours. So there's not long to go now, guys. The voltage will start dropping fairly quick on this. Be interesting to see how much it actually gets. So 12.3 on there, and it's saying 0%, which would make sense, but it's what's that, 85.7 amp hours as opposed to 91.3. So we'll just keep an eye on it towards the end there and see how we go. Clicked over 101.5 amp hours now at 10.85 volts. The voltage is starting to drop a little bit. Well, drop quickly I should say. And this battery is rated down to 10 volts, 2.5 volts per cell, like everything else. So let's see it go down. And we'll stay with it now until it cuts out. But look, it's met its rated capacity, so I can't complain. And at a reasonably high amperage discharge too. I mean, in the real world, you wouldn't discharge this thing at 790 watt continuous. So, yep, that's a win in terms of rated capacity. Got to admit, I'm pleasantly surprised by that. Okay, getting close now, guys. Okay, so the low voltage alarm on the inverter's now come on, and you can see it flashing here. So the inverter may trip before the BMS again, which you know I don't like. This thing should have cut out by now, and there we go. So the inverter cut off before the BMS did, and it was higher than, a lot lower than 10 volts, and we even saw it on there. So I don't like that, but it's no worse than a lot of other batteries. So it made its rated capacity, that's a pass. The terminals, they didn't really heat up, and yep, happy to eat my words on that one. But you know, as I said, loose terminals are not a good thing, and it really did leave a bad taste in my mouth when I first opened it up and found those loose terminals. That said, everything else seems to work on this unit. If you're looking for something like this, 100 amp hour capacity with the 40 amp DC charger in it, I really can't say why you wouldn't buy it. You know, loose terminals made it a fail at the beginning of the video, but now it all seems to work fine. So there you go, guys. If you're after the AtemPower Power Hub, I think they're available from Vic Off-Road and online, and I think they're around the just under $1,000 mark. All right, we'll end this one here. Thanks for watching. Stay tuned for more videos and stay safe.